GTA Math, what's up? Today we're gonna work on an integral that has a partial fraction in it. I got my hard work pays off shirt because I definitely worked hard to try to remember how to do these. So let's work. So the first thing we're gonna do is rewrite this radical that's in the denominator. So we're gonna end up with this. And if you don't remember the radical rules, I do have a video on that. So don't be a stranger. Go find that, watch it, refresh, all of that good stuff. So really we're gonna just bring this up to the top, and it's gonna be a negative exponent that's attached to the radical that was there. And then we're gonna put our dx. So since we have a degree of x squared inside of this negative exponent, we have to make sure that in order to integrate, all of this is in terms of x. So what we're gonna do is u substitute this portion of the function. So we're gonna say u equals x squared plus 1. And then we're gonna put our dx here. And the next thing we're gonna do is we're gonna rewrite this, and it's gonna look like this. So we're gonna have this integral, and we're gonna have x times u to the negative 1/2 dx. And our goal is to make sure that everything I underline is gonna be substituted in terms of u, well, du. So we're gonna come back up here to our u substitution part, and we're gonna do this in 3 steps. The second thing we're gonna do is we're gonna take the derivative. So we're gonna end up with du equals 2x dx. And we gotta make sure that this is in terms of x dx as I underlined before. And in order to do that, we're gonna divide this 2 that's here out of this function, well, equation. So now we're gonna end up with 1/2 du equals x dx, which is perfect because that's actually what we wanted, because now we can sub this in for the x dx we have. So I'm going to show you what that looks like. Now we're going to rewrite this, and we're going to have this integral symbol, and we're going to have 1/2 here, and we're going to have our u to the negative 1/2. And now this is all in terms of du, because we're taking the derivative in relationship to u instead of x now. So we're gonna have our du here. And we're gonna factor this 1/2 out as a constant, and we're gonna end up with this. This is one of the rules you can use that's a part of integration. You can factor out constants. If you don't remember that, do your research. So now that we're at this step, we're gonna actually take the antiderivative of this portion of the integral. I like to just make a little bar and then I just take the antiderivative here. And what we're gonna do is say, all right, well, we have u to the negative 1/2. And when we take the antiderivative, we add 1 and we divide by the new exponent. So negative 1/2 plus 2/2, which is the same thing as 1, is going to give us 1/2. So now we're going to be left with u to the 1/2, and we're going to divide it by this new exponent of 1/2. And we're really going to just take the reciprocal of this, and we're going to multiply it. That's a bad step. I'm gonna erase that. And this is what it's gonna look like. So now we're gonna have 1/2 and then we're going to have 2u to the 1/2 plus c. So all we did was we added 1 to this u function, and we divided that by the new exponent. So what that looks like, I'll do it again. We ended up with the new exponent of 1/2. So we said, all right, we have u to the 1/2 divided by 1/2, which became 2u to the 1/2. Oh, that's not what I wanted to happen. But you get what I'm saying. And this is what we ended up with. And we plug this in here. Now we're going to simplify, and we're going to end up with this. We're going to have 1/2 times 2u to the 1/2 plus c. This is going to cancel, and we're going to be left with u to the 1/2 plus c. Now we're going to take our original substituted portion of u that we used earlier in this problem, this, and we're going to plug it back in to our equation. So we're going to end up with this. We're going to take this x squared plus 1, and we're going to sub it in back for u, and we're going to end up with this. We're going to have x squared plus 1 to the 1/2 plus c, and this is our final answer. So we just took the integral of a partial fraction. GTA Math, I appreciate you for sticking with me. This is a little bit tougher of a problem, but practice, 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 and you'll be all right. So I appreciate it. Thank you for showing up. Let's continue to learn, love, and grow on this journey we call life. Take care.